Hello and welcome to this video. So the diagram shows 4 semicircles placed symmetrically between 2 circles. The inner circle has area 4 and each semicircle has area 18. What is the area of the outer circle? This problem is taken from the Senior Maths Challenge. If you wish to try and solve it yourself, pause the video now. Now we're going to go through it. Okay, so what we want to find is the radius of the big circle. So how will we do this? Well, we know the areas of the small circles and the semicircles, so let's find their radii. The inner circle area is 4, so pi r1 squared equals 4, meaning that r1 squared equals 4 over pi, so the radius of the small circle is 2 over pi. Now for the semicircle, its area is 18, but we must remember to divide by 2 using the formula for the area of a circle because it's a semicircle. So pi r2 squared divided by 2 equals 18. This means that r2 squared equals 36 divided by pi. So r squared equals 6 divided by pi. Okay, so now we have the radius of the small circle and the radius of the semicircle. So what we can see here is that if we arrange it like this, we've actually got a right angled triangle, meaning that we can use the Pythagorean theorem, which is a squared plus b squared equals c squared, and in this case it will be r1 plus r2 squared plus r2 squared equals r squared, which is the radius of the big circle. So now let's substitute our values for r1 and r2 into this. And this gives us r squared equals 100 over pi, meaning that the radius of the big circle is 10 divided by pi. So now all that's left is to put this into the area of a circle, which is pi r squared, giving us pi times 100 over pi. And because we have pi on both sides, we can just cancel that out, giving us an area of 100. And this is the answer. Thanks for watching, and until next time, goodbye.